Hi viewers. So before watching this video, please subscribe it. And today's topic is very important, not only for the exam point of view and also for knowing, for remembering, or for higher education also. So what is that? So this is the Maxwell's equations in differential forms. Integral form also written, but a derivation is from integral to differentiation. Okay friends, let me start. Please listen carefully, it is very important. The basic laws of electricity and magnetism in the form of four fundamental equations are there, that is Maxwell equations. These equations are known as Maxwell's equations. The integral form of Maxwell's equations are integral over a closed circuit or closed loop, that is integrals. Its meaning is over a closed loop. Okay, so integral E dot ds is equals to q by epsilon naught. In integral form it is. Next, integral b dot ds is equals to 0. Next, integral e dot dl is equals to minus d phi b by dt, and sometime it is also written as dou phi b by dou t. Don't get confusion. So minus dou phi by dou t, nothing will happen. Next, last one is in integral form, b dot dl is equals to mu naught into j plus epsilon naught dou e by dou t. Okay friends, these are the 3 or 4 integral form of Maxwell's equations. And next, Maxwell's equations in differential form. Div or del dot E. Div means divergence E, or del dot E is equals to rho by epsilon naught. Divergence B or del dot B is equals to 0. Curl E or del cross E is equals to minus dou B by dou T. Curl B or del cross B is equals to mu naught into J plus epsilon naught into dou E by dou T. So like this friends, these are the 4 differential and integral forms are very important. Okay, let me start. First equation. Derivation of Maxwell's equation in differential form from integral form. So first equation, see what is the first equation. So from Gauss law of electrostatic. So this is the formula of Gauss law in integral and electrostatics only. Okay, right. Gauss law from Gauss law of electrostatic. Let it is equation 1. Integral E dot ds equals to q by epsilon naught. If rho be the charge density and dv be the small volume considered. Okay, so that means let rho is the charge density and dv is the small volume. Then what we can write? We write simply, it is like this. How we got this one, you know? We know the rho is equals to charge, it is a volume charge density, charge by volume, and we can write from this charge is equals to rho v. For the small volume, when the volume is very small, then charge is also small, less charge is present. When the volume is more charge is present. When the volume is less charge is present. Now integrate on both sides within the volume v. Then what do you get here? Integration, differentiation cancel. Here q only. Q is equals to integral rho dv. Okay friends, how does it comes? Like that it comes. Okay, so if you want to listen again it by keeping and resume, by stopping it. Okay, now substituting in equation 1. In this equation, in the place of q, substitute this formula. So then we got this one, Yes, from this bring epsilon naught this side, so now it is like this. Okay, and epsilon naught into E is what? D, right? We know already that is. Okay, so this is the equation. Now CD is here in volume, in area, it is in volume. DS means small area, dV means small volume. Okay, so convert this is into dB. If you want to convert the area into volume, then which theorem we have to use? Gauss theorem of divergence. So use now Gauss theorem of divergence. By using Gauss theorem of divergence, see here. So it is Gauss theorem of divergence formula. When you have the vector like this with a ds, it is converted into del dot A into dV. So area is converted into volume, and in the place of A, del dot A has come. Now here it is the d you have, so it easily converts like this. It easily converts in this manner. So integral del dot ds is equals to del dot d into dv. Okay, now substitute this value here like this. Now these two equal. Now it is integral, it is integration, this is dv, it is also dv. Now in the place of del dot d, what you have? Rho you have. So final answer is del dot d is equals to rho only. So this is. Okay friends, how does it has come? So like this. And again, if you want to write, so actually up to here only. So as you wish, you can write up by convert in terms of E also. If you want to write in terms of E, write substitute in the place of D this one, and bring epsilon on this side, it becomes, so this is, it is in terms of words. Div E is equals to rho by epsilon naught. Okay friends, so this is differential form of Maxwell first equation. Next, Maxwell second equation, let me see. Okay, Maxwell first equation from electrostatic we got, and Maxwell second equation see from magnetostatic. So it is a magnetostatic formula. Integral B dot ds is equals to 0. So it means it can explain to us magnets does not having monopole. They does not have monopole. Monopole means if you have a bar magnet, if you break this bar magnet, you cannot separate it as a north and a south separately. If you break the magnet into small pieces, then each piece contains north and south. So that means always in the form of pair only they present. They cannot present single north, single south cannot be present. So that means single means mono. So monopole doesn't exist, that is the meaning of this. Okay, next, according to the Gauss theorem of divergence, so it is volume area, convert, just now I explained you, convert into volume, then del will come, see, like this, del dot b into dv, it is, see, area is converted into volume. So Gauss theorem is simply converting the area into volume. Stokes theorem is converting from length to area. Okay, like this only. Yes, it is written like this, and this is already we know this is equals to 0. Then see, when it is 0, then del dot b is also 0. Why? See here, this equation is 0, then this is also 0. So this 0 means this is equals to 0. See, it is equals to 0 is written. When it is 0, del dot b is also 0. So this is the Maxwell second equation. Okay friends, what Maxwell second equation explained to us? Monopole does not exist, means two poles exist, one is north, other one is south. We cannot separate north from south. Next, third equation from Faraday's law of electromagnetic induction. So it is a Faraday's law, right? So what is the Faraday's law? Right? So it is integral form of Faraday's law. So Faraday's law is what in electromagnetic induction? Integral E dot dl is equals to minus d phi b by dt. Okay friends, now so this is how we got this formula. Actually B definition is magnetic flux per area. Okay, so B definition is what? B is equals to phi by area. Let area as S. From this phi can be written as BS. If the small area is there, then phi means the flux is also small. Integrate on both sides. Integration differentiation cancel. So what we got? Phi is equals to integral B ds. What? Phi is equals to integral B ds. Now see here. Right? How we got this one? And take this value and substitute where in this equation in the place of phi b. Then we get this one. When we substitute here, we get this one. Now integral E dot ds is equals to integral, it is see this totally multiply inside. Now it is becomes minus dou b by dou t dot ds. Okay, so apply to this what? Stokes theorem. So it is simply length. We can convert into area by keeping del cross A. So see, length is converted into area, and in the place of A, del cross A has come. Okay, so it is Stokes law. So what is Gauss law? Gauss law is area is converted into volume. Okay, but del dot will come. Del dot will come. Here del cross will come. That is the difference between Gauss law and Stokes law, Stokes theorem. So Stokes theorem is this. Apply the Stokes theorem to this only, this integral. Then we get this one and substitute here. Then this is right. Okay friends, what we have done? Simply this is substituted here and equated to this. So we got this one. Now it is ds. Ds integral v integral. It is not s. It is also v. Yes, so sorry, it is not a v, it is yes, it is yes only, it is not a v. So then see in the place of del cross E, what you have? This one. Okay friends, so it is not, if it is a yes, then it is also yes, not volume. Okay, then it is a ds cancel, integral cancel, and del cross E is equals to this one. Del cross can be written as curl E minus dou b by dou t. It is Maxwell third equation in differential form. Next, Maxwell fourth equation in differential form. See here. So from the Ampere's law, so this is Ampere's law in integral form, and I how we got? See here, J is current density, current by area. Let area is S. So from this I is equals to J into S. Bring this J this side, IS this side, then we can write like this. So when the area is small, then current is also small. Through the small area, small current will flow. Now integrate on both sides. Here integration differentiation cancel. Then I is equals to, here I only, I is equals to integral J ds. But here integration differentiation cannot be cancelled. Why? Because in between the integration and differentiation something is there, but here nothing is there. So that is why these two gets cancelled. Here we cannot cancel them because something is there. Okay, when there is no something, then they get cancelled directly. So in the place of I, substituted this one. Okay, now apply the Stokes theorem to this one only. This is the Stokes theorem. Apply it. When Stokes theorem is applied, so B converted into like this, dl is a ds simply only, B is a del cross B only. Okay, and let equation, it is equation 6 and 7. So B dot dl, so B dot dl, what we got? We got it, this is, and substitute here, then we get this one. Okay, when substitute this here, then we get this one. Okay friends, alright, it is D. Now keep it like this only, without doing anything, but simply multiply this mu naught inside, then it becomes mu naught into J. Now see, ds cancel, integration cancel. In the place of del cross b, what you have, this is, okay. So del cross b is equals to mu naught into j, but it is not modified. It is valid for only steady or static current. I explained in the previous video. Please watch displacement current or modified Ampere's law. So here j can be replaced by j plus epsilon naught dou E by dou t. So in the place of j, only in the place of j, substitute this total, then we get this one. So it is after modification, this formula we got. So this is the Maxwell fourth equation. Now these four equations we have to apply to the free space, and free space means vacuum, and as well as for dielectric. Okay, once again see the four equations. What are those? In differential form only we need, it is del dot E is equals to rho by epsilon naught, del dot B is equals to 0, del cross E is equals to minus dou B by dou t, del cross B is equals to mu naught j plus epsilon naught dou E by dou t. Here two dots are there, two cross are there, but EB, okay, EB, first two are dots, next two are cross in integral form. EB same, ds dl, ds dl. Okay, next applying to the vacuum. Vacuum means free space. Let us apply the Maxwell equations to free space or vacuum. Where there is no charges and no currents to interact. But actually in free space current cannot flow. No current means current density is 0. When there is no current, no charges also present, then charge density is also 0. Current density and charge density both are 0 in free space. Why? Because free charges cannot be available. Free charges, no charges means no charge density. No charges flowing means no current density. That means rho value and j values are zeros. Okay, so rho 0, j 0. And permittivity and permeability in vacuum. In vacuum, these are denoted by epsilon naught and mu naught. Okay, hence Maxwell equations in free space are, see, actually here Maxwell equation is del dot E is equals to rho, del dot D is equals to, or del dot E only. Why? Because in terms of E only given, del dot E is equals to rho by epsilon naught. Just now I told you rho value 0, then this is 0. It is already 0. It is no changes, right? This is what, see, actually what were there? J plus epsilon naught dou E by dou t there, but j value is 0. Just now I explained you. Then this term remains only here. Okay friends, like this. Next for dielectric. So for dielectric, see here, Maxwell equations in dielectric. Dielectric medium can act as an insulator. That is why no free current. There is no current means j value is 0. And free charges. So free charges also cannot be available. Why? Charges present but bounded charges present. So free charges are 0 and free current also not there. So 0. So same thing what we have explained in the above, like this. Del dot E is equals to rho by epsilon naught. Rho value 0 means this one also 0. It is automatic 0 and this also no change. But it is again here. Here permittivity and permeability in dielectric are denoted by epsilon and mu only. Not epsilon naught. Don't write epsilon naught and mu naught in dielectric medium. In free space only like this we have to write. But in dielectric medium, epsilon and mu only. Okay. Right, and see this formula is in dielectric medium. Del cross B is equals to mu into j plus epsilon dou E by dou t. So here J value is 0. Then multiply this inside. We get this one. What? Del cross B is equals to mu epsilon dou E by dou T only. That's it. Okay friends, so this is very important, so don't forget. So you must keep in mind integral form and differential form. Okay friends, thank you.